Good morning, average engineers. Today I'm going to talk about how tech debt, Databricks, and Spark UDFs ruined my weekend. It's basically a lesson in tech debt. Let's be honest, we've all spent our time working on the weekends. Me too. I've had a long data engineering career, over a decade, and pretty much all of us, no matter what kind of team you work on, no matter how good you think you are, we all end up working on the weekends because sometimes things break. I've worked on tiny teams, I've worked on big teams, good teams, bad teams. It doesn't really matter. It's just a fact of life. It happens. We can kind of kick our feet up and think as engineers we got the best stack, there's nothing wrong, and then, something breaks on a Saturday. I figured my tale of woe would serve as a good lesson for all the data engineers out there, how to stay humble and how to keep on the offensive and how to deal with tech debt and think about tech debt. Let's talk about tech debt for a minute. It seems like tech debt gets a little bit of love, but not much on the internet. It's really not that sexy to talk about tech debt. It just doesn't get that much focus. I mean, you hear about it here and there, but it's just not something that you hear a lot of people talk about all the time. It's sort of a boring topic, but I think it's all something we live with, on every data team. We kind of cuddle up to it, pat it on the head. We all know where the tech debt's at. If I asked you in your data platform, where's your tech debt, you could probably tell me. Basically, tech debt is the concept of incurring future costs due to taking shortcuts or suboptimal decisions during the development process for whatever reason. It just might be the culture you work in. You have to move fast, deliver something. You make trade-offs. That's part of engineering. And that stuff over time can add up as tech debt. I'm sure there's some people who say, there's no tech debt on my platform, but let's be the reality. 99% of the data platforms that we work on occur tech debt over time. If you look at this image, basically the amount of code written goes up exponentially over time. The time passes us by. Technical debt is probably going to increase unless you're dealing with it on a regular basis. Most people think about tech debt as bad code, and that's true to an extent, but that's not all encompassing of what tech debt actually is. On the average data platform, there are lots of types of technical debt just besides bad code. Yes, it can be bad or complex code. It could be things like old architecture, systems getting old. It could be vendor features and platforms that are maybe, going defunct and you're not keeping pace with the new releases. It could be data quality. It could be your data monitoring and alerts. It could be poor CI/CD and DevOps practices. All of these combined together create complex tech debt that's more than just, this function is messy and bad. If you think about all those things I just listed, they can all kind of intertwine with each other, and they can end up creating, some more complex technical debt that has to be dealt with. That's more than just, hey, I'm going to clean up this method or function. And listen, I'm not saying every kind of tech debt is bad. I think it's a normal part of the engineering process. I think it depends on the size of company you work in. I think it depends on the culture of the company and how fast and technical your team is, how quick you move, and how quickly you're expected to deliver features and products. The truth is we can't have our cake and eat it too. There are trade-offs we make every single day on data platforms. That's part of being engineers. We just consider what lies ahead and behind, and given our tasks, we make certain decisions. And some of that, we accept technical debt in some areas, and sometimes we reject it and fix it. And to give you an example, I'm going to talk about again how my weekend got ruined. I'm just going to give you like a high level, this is what happened, this is what I did, and this is kind of the things that led to this happening. It was just like, talk about it, and let's just look at it as like, this is how tech debt can normally appear, and these are the problems it can cause. So I'm going to give you the stories here. It all started at 4:45 a.m. on a Saturday morning. Yeah, of course. Slack alert on my phone, pipeline failure, 4:45 on a Saturday morning, out of the blue. I mean, seriously. So this particular Slack alert was sent from Airflow from a Databricks pipeline, and the following Spark error appeared in the logs. It was kind of, I've seen a lot of Spark in my life, been around it a ton. This one, I thought I knew what was going on. Maybe, here's the error. It said failed. The execution environment was lost during execution. This may be caused by code crashing or process exiting permanently. This is a fairly cryptic Spark message. The first thing that came to my mind, and probably anyone else who's worked with Spark, was that, hey, are there some memory issues going on here? Is this thing crashing, something collecting on the driver? It just kind of like seemed obvious. A little context, the months before this error, we'd been working on a migration from standard Databricks account to Unity Catalog, and it had been done and it had been working successfully for probably about a month when this error happened. And again, I saw this error and thought, man, this is out of memory thing. I think something's going on the driver node. poof. It's going poof for some reason, that driver node, and it's probably memory related. It'd be strange if it wasn't. To give you context, it is a few 100 billion records, so it's quite a large data set, but again, remember this pipeline had been running without problems for over a month, so it wasn't necessarily so clear what was going on. Some of the stuff I did to try to fix it, I went and looked at data volumes to see if there had been any spike or anything in data, and that was not the case. Data volume steady, nothing had changed there. I also increased the cluster size and driver size up to 1 terabyte of RAM on the driver just to get the pipeline to pass. Remember, this is on a Saturday morning, 4:45. I didn't want to work on this all weekend. I'm just like, I'm going to throw some stuff at this. I want it running and fixed. I don't want to deal with this. And unfortunately, the terabyte of RAM on the driver, along with looking at the data volumes, nothing had changed at all. Didn't fix the issue. So then I start thinking, man, something else must be going on. Again, I increased the whole cluster size, and I actually increased the disk size on the cluster, on volumes attached to the cluster. I tried changing the DBR runtimes, thinking, man, what is going on? It's something weird. I tried downgrading, upgrading, nothing was working. I even tried adding some catching and persisting of intermediate data sets just to try to get this thing to run, and I couldn't get anything else than this node was the driver node is basically just going poof midway through, just disappearing with that vague error, and it clearly was not memory related at this point. This was kind of hard for a Saturday, right? Now I'm a couple hours in and it looks like my Saturday is shot. Now I want to pan back about a couple years and talk about what had happened with this entire data platform. This data platform used to be AWS EMR for Spark with some EC2 instances, along with AWS Pipeline for orchestration, and it's a data lake, just raw Parquet files in S3. We had done a big project to migrate to Airflow and Databricks along with Delta Lake and kind of upgraded that whole thing. We thought we were good to go. Just to give you some background, this data platform is a complex machine learning pipeline. The code in the past, prior to the migration, was kind of unusable, no tests, poorly written, excessive UDFs, loops, a mix of Python and PySpark. It was terrible. So during this migration to Databricks and Airflow and Delta Lake, things have been unit tested, the code had been cleaned up, it was just been running for years, just like top notch, no problem. This was pipelines that were taking 18 plus hours to run down to like an hour and a half. It's a beautiful system. But this error, and I'll get into it, was a classic case of technical debt not being totally dealt with. So again, remember, Saturday morning, 4:45, and now it's about 11 a.m. in the morning with no end in sight. I haven't figured this out. I've kind of thrown everything obvious at it. It's clearly was some underlying issue that came out of nowhere. Again, remember I talked about this pipeline migration that happened a few years ago. That entire process was like a year and a half long because it was a complete overhaul. Most of the code had been rewritten, brought over like I talked about. Well, there were a few pieces that had been kind of shoved to the side, and of course this was one of those pieces. Again, talking technical, that 99% of the pipeline and the architecture had been moved over. There was just a little bit, that 1% left that had been left for whatever reason, had been left in a semi-migrated state. And what I mean by semi-migrated state, I mean that terrible code from the past that I talked about had just kind of picked up, thrown inside a Databricks notebook, was running on an older version of DBR and just running like that. It really hadn't been touched. The code hadn't been touched enough. It was still in its old state, extremely hard to troubleshoot, to look at, full of UDFs, full of a bunch of terrible things. And it just been, like I said, plopped into a notebook and just let run over on the new system, thinking that, kind of like that was like a halfway step for whatever reason on this 1%, even though it was a critical piece. It just hadn't been taken over the finish line. So what I found was when I downgraded and started playing with these DBR versions, downgrade and upgrade, all of a sudden I started to get more errors in this pipeline that was referring to UDFs. Now this was, like I talked about, this old code was full of them. There's well over 25 UDFs, totally unnecessary, inside this code that had never been refactored. So now I was getting somewhere. It's in the afternoon, it's Saturday, I'm angry, and it's clearly that there's something deeper going on here. It's clearly something in the background had changed, because remember, this pipeline had been running without problems, even though it was a crappy pipeline that hadn't been updated, but something magically had changed somewhere, causing some UDF errors to be thrown. In the heat of the moment, I almost went down the path of, what am I going to sit here and refactor all these 25 UDFs into normal PySpark functions on a Saturday without really testing them and going through the PR process and just try to make this thing run? I mean, it was kind of tempting, but I decided against that, because such changes, they need rigorous testing. Doing things in the heat of the moment probably was going to mess something up, and going down that rabbit hole is probably not going to what I needed to do right now. I just need to fix this thing and get it running. So making decisions under pressure is hard. You debug for hours. Do you call for help from someone? It's Saturday. Do you refactor the whole thing? Do you, what do you do? Play with configurations, revert back. What was I going to do? What could I do at this point? Now, this is a lesson in getting lucky and being very careful with vendors, even great vendors like Databricks. This is especially true if you have a code base that is relying 100% on a particular vendor, especially a fairly new one. It can be a foot gun or ticking time bomb if you don't have anything to fall back on. Again, I was getting desperate on my Saturday to get this thing fixed, and it wasn't clear what steps I should take, but I got lucky. When I talked about that migration we had gone through and we'd migrated all that code, just tons of it, when we had upgraded Databricks standard account to Unity catalog, all that kind of stuff, gone through it and everything was running great. We'd actually left, we hadn't torn down the old account, the pre-Unity catalog account in Databricks. So some stroke of luck, whatever, maybe just a little bit of trust on our part. We hadn't torn that down yet. We had left it sitting there, and I remembered that. So you know what I did? It took me 5 minutes. I took that notebook that was running in Unity catalog, I took it, I pasted all that code back over into a notebook in the old account, in Databricks, a standard account, attached it to a cluster, ran it, boom, done, set up a job, attached that notebook. Now again, if you've listened to me, you know I'm not a fan of notebooks, but again, this is Saturday, I wanted to get it done, better safe than sorry. I just wanted to take that same code because I knew it had been running before, in the old account before we migrated, and it had been running the new account with some chance. Again, I'd done a little research and seen that, the Unity catalog doesn't play with UDFs very nice. It can, like certain DBR versions, once you hit like 25 UDFs, it blows up, doesn't like it. What am I going to do? Am I going to fix it? No, it's Saturday. I'm just going to try run it in the old account. So that's all I did, and it worked. This is just a couple lessons that I learned from that. No pipeline is immune to failure, no matter how long it has been running fine. If you have tech debt hidden somewhere, it's very likely that pipeline can just blow without note, and you better have a backup plan. And when you're thinking about working with vendors like Databricks, Snowflake, and your entire platform, your entire pipelines to rely completely 100% on this thing, or one thing working perfectly, that's sort of okay, because a lot of these tools never go down, but there are going to be times like this, like what happened with me, because of tech debt, because of code, things out of your control, things are going to break, and you need to have a plan. You need to have a backup plan. How can I run this pipeline in the worst case scenario? And tech debt we are our own worst enemies. If we don't deal with this tech debt, if we do 99% and we leave that 1%, apparently that 1% will eventually bite you in the leg. There are lots of types of tech debt that are not just bad code. A lot of times bad code has a part of that, but there's also architecture, things like that will catch up with you. When it comes to tech debt, you should try to keep that tech debt level, try to get it declining or at least staying steady. You don't want it going up constantly over time. Again, when solving stressful problems like me at 4:45 and then all the way through my Saturday, try to resist the urge to do something complicated, especially if things have been running fine, you're getting stressed, you can't figure out what the problem is. You just want this pipeline to run. You can start changing code, doing all crazy stuff that you probably shouldn't do. Keep it simple, try to find the simplest solution possible. Again, we all take risks on our data platform. We decide what is important to work on, what isn't. We listen to the business, we solve problems, we keep things running, but we have a responsibility as data engineers to understand the dark corners and the edges that exist in our data platforms, to find them and to squash them. In my case, I simply got lucky that a leftover migration, we had left up an account, left up a platform that we didn't really need just in case, and I kind of remembered it was there, and I was just be able to go use it, and it ran. But that's probably was just an accident, and I got lucky. So it's hard in the moment of pressure to step back and think about all the options, but you never know. Even if you know, you could probably code your way out of it. Try to resist that, try to think the big picture and solve it. And so this is a lesson in tech debt and how Databricks Spark UDFs ruined my Saturday.